Doing every challenge question, this is the logs and exponentials chapter. So this graph here is just the graph y equals 2x transformed a bit. To get the minus 2, you just do f of x minus 2 in brackets, and to get the plus 5, you just add 5 afterwards. This is a shift 2 to the right and 5 up. This graph is just a regular exponential graph going through 0, 1. So this graph here actually looks the same if you don't bother putting any scale anywhere. And this coordinate here is just going to be when x is 0, which is 2 to the minus 2 plus 5. 2 to the minus 2 is a quarter, so that makes 5.25. And this is basically what I need to do, so that was nice and easy. I actually didn't bother doing it like this. I proved it in a way that I proved it in a previous video because I couldn't be bothered to retype anything. So I just let this equal z. You can raise take a to the power of both sides here. And when you do that, just take a to the power of everything over on this left side. And then a to the power of z over there. Now, you can, of course, say via the sort of exponential rule backwards, you can say that this is a to this divided by a to that, because that's when you take away powers, when you're dividing things with the same base. So just using that rule from GCSE backwards. But of course, a to this log a is just x, and a to log a of this is just y. So that makes x divided by y is this, that's x over y is this, and then take log to base a of both sides, and you end up with this. But of course, you define z to be this in the first place, so you end up proving the thing they wanted you to prove. So that was cool. The graph with function that passes through this and this. If y is 2 as an asymptote, just like the exponential we drew earlier, the standard exponential has an asymptote at y equals 0. So if it has an asymptote at y equals 2, that means it's been moved up 2 units. So therefore c is 2. So we can put that in immediately. Then when we also put in the information x equals 0, y equals 5, we get this using c as 2 at the end, and then this is 5 and this is 0. Of course, that's just 1, so a plus 2 is 5, so a is 3. And then we can finally put this information in to get 10 over here equals, we know a is 3, we know e to the bx, where x is 6, and then, of course, c was 2 from before. And we can just solve this for b by doing all the regular things, and we'll get the answer they want us to get. This question was really weird, but essentially you just need to know that it's in a chapter that's essentially all about deciding whether things are of the form this or of the form this. Like, that's all this chapter is. Now, this form is the more interesting one, in my opinion. When you take log to base anything you want of both sides, you eventually end up with this, which is just a linear relationship in x and log y. Right, so this is just a linear graph with y-axis log y and x-axis x, because this is just the form y equals m here, x plus c. So this is just a constant, which would act as the y-intercept. This is a constant that would act as the gradient, times by x, and then the y-axis is just the log y. So if I just do log y and work out log y of all these things, I'm doing this in the base e, by the way, because I'm, actually a mathematician. You get all of these numbers, and now what I'm looking for is those to have a consistent distance between them all. Because if they do, that means it's a linear relationship, and that linear gradient essentially will just be log b. And of course I do end up with it. It ends up being roughly this. So therefore log b is just this number here. Do e to the power both sides, because this was log b, log to base e, remember? You get b as that. And then of course you can just go back to this here up here and just substitute in 1, 5.22, and you'll find a pretty easily is 5.8. Bit of a weird question, to be honest. Given y is this, show this. So 9 is 3 to the power 2. 2 times x is 2x. Take log to base 3 of both sides, and you end up with this here. Hence, deduce this thing here. Well, from this starting point, you could have also just said log to base 9 of y equals x. When you double both sides, you get this, and then you can move this 2 up to here based on the power law. And of course, therefore, 2x equals this, and 2x also equals that, so therefore these two things are equal to each other. Use your answers to solve this thing here. So, okay, how do we use this to solve this? Well, it's telling me this, how to change log to base 3 of something into log to base 9 of something. So let's change this log to base 3 into log to base 9. All I have to do is square the input. So this becomes log to base 9 of this thing squared. And now, of course, log to base 9s can just cancel from both sides. We get this, we expand this thing out. We collect everything together on one side. That ends up factorizing, does it? It does, cool. So answers are -2 and -1/3. Just check that both of those things can actually go in here without causing any negative inputs in the logs. And they do, of course, because they're both negative. So this is positive, this is positive, this is positive, that's fine. And then, of course, this is positive, it's all fine, so that's good. Excellent, I think that's the whole thing.